Hey guys, how are you? We're on our third day. I maybe don't sound like it, but I'm doing a little better. All right, today in our simulation, instead of changing the number of particles to see the effect on pressure, we're changing the Kelvin temperature to see the effect on pressure. All right, and so that would be, in abbreviations, then the temperature is capital T with a subscript K to indicate it's in Kelvin, always in Kelvin for gases, versus the pressure. So this is our temperature is our independent variable we're changing to see the effect numerically on the pressure. All right. So we're going to run this second one. And so I made you a data table. All right, and you can choose these temperatures. If you want to add other points, feel free to. In fact, why don't we just do this so that you could add any points if you wanted to the data table. All right? You don't have to just take the ones I picked. Notice I picked a range of variables from 50 degrees Kelvin all the way to 800 Kelvin. So I picked a pretty wide range. Then, of course, we're going to want to hold the other two variables, volume and the number of particles, constants. All right? So, we're going to want to go to the simulation. And let's go to, let me go where I gave you that link. All right, on yesterday's assignment. All right. Whoops, that's not the one I want. So we're going to do the same thing as yesterday. Well, I can't find my link. So what we'll do instead, all right, let's go to the PhET simulation. Oops. That will be the title of it, Introduction to a Gas. All right, so now I'll just go to do an internet search. Whoops. Let's go to PhET simulations. I will type in and then see how it's going to appear. Gases intro. Ideal gas. All right, and it's going to open our simulation from yesterday. All right, so I'll just open it. All right, here's our little system again. And there. All right. Now, we're going to want to keep the volume of the container constant. Once again, we can make it changes. We could leave it kind of in the middle, like we had yesterday. And up here at the top, I'm checking the width. All right, this is 10.1. All right. Now, we want to be able to change the temperature, but we want the pressure to remain constant. So I want you to, let's go back to the previous page on this, and let's go to the laws one, because it gives us just a little more ability to fix what we need. It'll actually make us be able to keep things constant. So I'll take back that and put it on our page. All right. So I'm doing these things because without me being there, I have to be more specific. All right. So that's what we're finding. We're looking for this one. And okay. And so that's what you will get. I'm going to go back to the simulation. All right. Now this gives us more controls. Notice how now we can keep things constant, but otherwise it looks the same as yesterday. All right. I'm doing width again. All right. We have 10. And here is the temperature that will be changing. And we're going to affect the pressure on temperature. We'll want to hold constant that volume, right? And we're going to want to hold constant the particles. So I'm going to click on particles here. Let's just use the heavy ones because they're easier to see. All right, and we started with 50, 100, 200, 300. Why don't we go to, mid-range of what we had done before. 50, 100, 150. We want our pressure right here to stay fairly low. So that looks low enough, don't you? I would say 150 is fine. Yeah. If you wanted to, you could even go down to 100 because that lowers it even more. I'll do that right here just to demonstrate. All right. Now, we have a constant volume. The particle is going to stay constant here, so we aren't going to need to adjust anything. We have our two constant variables. Now we're going to have to heat this up, get this at the temperatures that were listed on our data table. All right, so let me get this set up. Isn't this wonderful the way we can do this and have the data table right next to the simulation when we're doing them? So we kept the volume at 10. Remember, we want all of those significant digits. All right, and that was right here. And according to this, it says it's in nanometers. All right, and now the temperature, it says to start at 50. So I'm going to start cooling this by pulling down on that lever. Look how fast it's falling. All right. 121. I wanted to start 50. That's a very low temperature. Yes, a very low temperature. Now I'm starting to be more gentle with a temperature drop. All right. All right, I have 51. All right, let's see if I can just wiggle it a little. Okay, I've got it at 50. Now notice how sluggish the particles have become. That's indicative of the fact that we're moving towards absolute zero, which is 0 Kelvin, where there's minimal particle motion. All right. Now, when we look at the temperature gauge, we can see, oh my goodness, we are really low. The atmosphere's 1.9 atmospheres of pressure. 1.9 atmospheres. And remember, we held this constant at 100 or 150, whatever you chose to do. I'm awfully low here, so if you chose 150, you might have been slightly better off here. All right, now we're going to keep adding. We're going to increase the temperature using the fire bucket. All right, we're going up to 100. All right, 97, 101. All right, 100. All right. And the next one says 3.9. All right, and then I want you to continue. All right, so when you get this part done and you have the data table finished, all right, what I want you to do is, if you had trouble with this yesterday, we're just going to go to the search here and type in company portal, and we want the company portal app. When it opens, you shouldn't have to use administrator privileges or anything to open it, because this was given to you on your student portal. All right, so this is a teacher portal, so what I'm going to do here is, let me move